Welcome to another episode of Data in Charge. Today we'll be talking about adaptive learning on streaming data coming from the IoT networks. My name is Adam Majcher. I'm a pre-sales engineer here at Volt Active Data. Our agenda will focus on the first problem statement, what kind of issue we are trying to solve. Then we'll go into architectural overview, how the whole pipeline is designed and how you can solve it with using Volt Active Data product. Then we'll jump onto the live demonstration to show the system actually running and processing all the events. And at the end, we'll have a summary of what we did during it. So currently, we have very fast growing IoT network. It is expected that around 38 billion connected IoT devices will be there by year 2030. It means that we have more and more devices connected to the public network. They are all quite frequently related to the critical infrastructure. So cyber attacks are pretty important consideration for designing this kind of systems, how they communicate with one another, and we should have some kind of real-time platform to detect this kind of threats, because the manufacturing downtime cost can be more than $50,000 per minute. It of course depends on what kind of the IoT system we are dealing with here, but in general this is a quite big issue for all the big companies. So the safety systems should react actually very quickly within milliseconds, because otherwise the damage can already be done. So what do we have in the IoT streaming data reality? We have usually some sensors readings which are being sent every few seconds. So if you have hundreds of thousands of these, the amount of traffic is pretty significant. This traffic can be monitored using just a standard network equipment. For example, with NetFlow, IPFix, just to analyze where all of this traffic is originating from and what is going to. Within this data, we have, of course, the standard traffic, which is benign traffic, but we also have all the hostile traffic, which we'll try to detect during this demo. Traditional approach is usually a bit too slow, because it is just collecting data and storing and doing some kind of batch processing with it. Then the reaction when it is done, it is actually too late. So what we are trying to do here is do some kind of streaming analytics, which will lead us to real-time detection and real-time actions on specific threats. So in our demo, we are getting the events which represent the flows, network data flows, similar to NetFlow IPFix protocols, which can be published from edge routers. They can be published from some monitoring tools. These flows usually contain port numbers, protocols used, packet counts, how many data was actually sent, as well as flow duration, timing, TCP flags. So all of this has been used for training our ML model to get very fast decision-based ML model and to use it within our streaming pipeline. On top of the model, we have also Kafka, where we are reading the events from the network. Then it is going into our Vault for Streaming Decision, V4SD, where we have all the pipeline defined. And so we have there our model, we have there our storage for the cache and also for the aggregated data. So you can see here the architecture. We are reading the events from Kafka source, then the ML model is classifying them to one of the 8 classes, one being benign, and 7 of them are different types of attacks. So it can be DDoS, it can be recon, it can be brute force, it can be Mirai virus, for example. After the specific event is marked with the class, it is being sent to the VoltDB caching. So this is our VoltDB database, based on which we are using our UI visualization tool to show what is actually happening, what kind of attacks are there, and how many of them we have in the network. Then from the VoltDB cache, it is going into a windowing feature where we aggregate some more grouped information. So how many of each attack is there, and this is used later for a more statistical overview where we don't need the raw data already. In here, we can, of course, expand the demo in the future, just using, for example, VoltDB caching to put the information back into the ML model. For example, correlating flows originating from the same source IP, which was earlier marked as hostile, to have better probability for some hostile traffic, right? So this is very simple approach which can be used here. Now let's jump into the live demo. Okay, so we have our demo up and running. We can see here the US map with some routers interconnected. This can represent your private APNs, the edge routers interconnected with one another, and we can monitor the network flows between them. If we hover over one of the connections, we can see if there is any attack ongoing, how much of the traffic is marked as DDoS, benign, and other classes. Of course, this is a bit increased in relation to how normal healthy network will look like, but it is just to show how the whole stream processing is working. You can see this is updated live. So the connections are changing with different attacks being done on different connections between the routers. We can check out our overview as well. So how many events we processed. So we have 2.8 million from the start of the demo. How many attacks we detected. We have right now the configuration with 12 vCPUs up and running. And we are processing around 50,000 events per second. This means we have around 4,000 transactions done per vCPU. And as you can see, the latency, it should be around 10 milliseconds. The data which is kept in cache is only there for 5 minutes. So of course the database will grow for around 5 minutes, then it should be around the same size all the time. We have also some more information here about alert quantities, attack distribution. So you can see that most of it is, of course, the benign traffic, and we have some information what kind of other attack classes are there, and the attack distribution, which is being updated here. Our visualization tool is just checking with VoltDB cache with some materialized views, what is actually the most common attack in the network. Here we have also some classification for the priority of specific alerts categories. This is the way we configured it, but of course you can configure your own setup. The same is with the ML model. Here we used a very simple linear regression model, but we are supporting all the Onyx models available out there. So you can use any model supported by Onyx framework. It can be light GPM. It can be anything what is actually available there for Onyx. So as you can see, the latencies are still very low, being given around 2 milliseconds for each transaction, with some spikes from time to time when we are cleaning data, when we have some aggregation being done. Overall, we are usually delivering SLA of P99 being below 10 milliseconds. So what are the key takeaways from today's demo? With Volt for streaming decisions, you can get ultra low latency and high scale product for stream processing, which will deliver less than 10 milliseconds processing capabilities to your system. We have also ML model management, so you can manage full life cycle and deployment of your ML models on your production environment. It is really easy to deploy the whole product. So this is how we differentiate from other streaming processing systems out there in the market. We are very flexible. We are using Java for definition of the stored procedures, and also the stream pipeline definition can be done in Java, in YAML. So it is really easy to configure everything. If you want to try, we have our Try Volt available there on our web page. There will be a link in the description below where you can just go and try the system yourself. And if you have any questions, you can reach out directly to me via LinkedIn or via email, and you will get all the aid for starting your own POC, starting your own demo, or prepare the architecture for your low latency and highly scalable stream processing. Thank you for your attention, and see you next time.